Hello, PreCalc. It's Monday. So let's look at our lesson for tonight. We have been studying sequences and series that are arithmetic, but we're going to introduce a different kind, another group of them. So copy this one down and marvel at it as you go. And we have seen this pop up in some of our work. 2, 4, 8, 6. The generator is 2 to the n. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. It works. So looking at this one, notice I do not add a number to get this number and the same number to get this one and the same number to get this one, because 2 to 4 is 2, 4 to 8 is 4, 8 to 16 is 8. So this is not what we have studied previously, which was called an arithmetic sequence. At that point, we were adding the same number to one term to get the next. But you can probably see from now this time, we are multiplying one term to get the next. I was going to say to obtain the next. How about to find the next? All right. When that's the case, and in this case, we see the number to get from one to the next is multiplying by 2. When that's the case, it's called the common ratio. If you recall, for the arithmetic sequence, it was the common difference. But this is the common ratio. In this case, it is 2, and we call it R for short. R equals 2. Notice R can be a positive number, but it can also be a negative number. What if we started with the first term is 2, and R was a negative 2 instead of a positive 2? What would this sequence look like? Well, we'd start with 2 times a minus 2 times a minus 2 times a minus 2, etc. So this time we see that we have 2 to the n times minus 1 to the n, or the n plus 1. I think in this case we need the first term to be positive, so when we put a 1 here, we need this to be an even number, causing the whole number to be positive. So a negative common ratio will cause this alteration of signs, and then it can also be less than 1. R can be 1/2. What if we start it with a sub 1 equals 10, and R was 1/2? Do you see we get 10 times a half times a half times a half, etc. So, oops, yeah. So 2.5 is 5/2 times a half is 5/4, and we can keep getting smaller and smaller as we go, with a positive fraction between 0 and 1. So all these are legit R's. They can be negative, they can be proper fractions, and they can be positive numbers. All right, let's come up with a formula for the nth term. Let me zoom in a little bit more. All right, the nth term. So we're going to look at, say, the very first term in, again, this new kind of sequence where we have common ratios is called a geometric sequence, where one term is multiplied by one number to get the next term and the same number to get the next term, and so forth. It's called a geometric sequence. And as you can see, let's try theoretically. The first term is a sub 1. So that's the first term. The second term is a sub 1 times R, the common ratio. The third term is the second term times R. So we have a sub 1 times R times R. So that's a sub 1 times R squared. And the fourth term is this term, a sub 1 r squared times r. So we get a sub 1 r cubed and so on. So what would the nth term look like? So anywhere we stop, we can call it the nth term, and we see that we have a pattern set up here, and the nth term is always going to be a sub 1 and an r to the what? Well, in the first term there was no r, in the second term there was 1, in the third term the exponent for r was 2, in the fourth term it was 3. So on the nth term, do you see what it's going to be? N minus 1. A sub 1 to r to the n minus 1. Hopefully you were able to write it down before I spoke it. This is the formula for the nth term in a geometric, where'd all that come from? A sub 1 r to the n minus 1. Alright, this is the nth term of a geometric sequence. All right. We have to keep those straight because in our thoughts, all right, I see your thought, Andrew, and you're saying, I remember from arithmetic sequence, it was a sub n equals a sub 1 plus n minus 1 times d, the common difference. So I am going to keep these straight in my head now that my thoughts are all out in the open. This is geometric, this is arithmetic. All right, so from this, we're going to kind of stay here for a bit. And I can do all kinds of wonderful problems. Suppose that the first term is known. The first term is known to be 20. And the common ratio is 1.05. So it said it can be a fraction. This one is represented as a decimal. Find the 20th term. So that's a sub 20. In order to find the 20th term, we're going to use this new formula. A sub n means a sub 20 is what we're looking for, equals the first term, which was given to be 20, times r. The common ratio is 1.05, raised to the n minus 1. This n and this n are the same, so we're looking for the 20th term, so this will be 20 minus 1, or 19. All right, calculating that, it should be at 39.599. All right. All right, you try the 12th term of this one. Say we have this geometric sequence. All right, and I want you to find the 12th term. All right, go ahead and pause and do that. Again, you're using this. All right, I'll try to catch up with you. A sub 12, the 12th term, is the first term, plus times the common difference. What did we multiply one term to get the next? 3. You can always tell by taking this term and dividing it by the previous term. 15 divided by 5 is 3. 45 divided by 15 is also 3. Any consecutive term divided by the term previous will give you the common ratio. And now we have to raise it to the n minus 1, which is 11. Did you get 885,735? All right, I'm hopeful. I'll end with this one. and it'll prepare you for your work tomorrow. Say I don't give you the first term, but I give you the fourth term. Let's say it's 125. And then I go way up to the 10th term, and I give you that. And it is a fraction. It's 125 over 64. Okay, so now I want you to find 14th term. So I like to think about what this looks like. So 1, 2, 3, 4. The fourth term is 125. So I'm going to fill in that blank. And then the 10th term, so that's 4, 5, 6, 7, 8, 9, 10. The 10th term is 125 over 64. And I want 11, 12, 13, 14. This is the one that I want. So there's several ways to do this, and you know that the common ratio to some number was multiplied by 125, and that number was multiplied by r again and got another number, and times r, times r, times r, and got to this number. So in a way, just for a moment, I can pretend this is my own little sequence, and this is the first term, and this is the sixth term. So that will help me get the r, which I can then apply to get the 14th term of the whole thing. So if I do that, so this is, can you see then that, how did I write that out? I said a sub 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A sub 10 equals, actually, a sub 10, what if I said a sub 6? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Fourth, fifth, sixth, 7, 8, 9, 10. So if I called this 1, 2, 3, 4, 5, 6, 7. I'm just messing. Let's say I did it differently on the paper, but it just came to me. What if I say a sub 7, if this is a sub 1, 2, 3, 4, 5, 6, 7, equals a sub 1 times r to the n minus 1. So filling in a sub r, a sub 7 is 125 over 64. A sub 1 is 125. R is what I'm looking for. And since we're talking about the seventh term here, 1, 2, 3, 4, 5, 6, 7. 7 minus 1, which is 6. I think this is going to work. 125 over 64 equals 125 r to the 6th. So again, recapping, the question started with giving me a fourth term and a 10th term, and wanted to know, the fourth term and the 10th term, and wanted to know the 14th term. But I see that I have information in between here. So I'm going to pretend this is the first term and this is the seventh term. The same r will operate inside this little sequence as well as this larger one. And that's what I really need to know. I need to know what r is. So back to work here. Is this something I can solve? All right, let us divide by 125 on both sides. So when I do that, this 125 will cancel this 125, and it leaves me 1 over 64 equals r to the 6th. So now I have to take the 6th root of 1 over 64. So the 6th root is what number times itself 6 times gives you 164. I bet it's 1/2. 2 times 2 is 4, times 2 is 8, times 2 is 16, 32. Yep, It is 1/2 equals r. So we found the common ratio. Now we can come back up here and find this spot right here. All right, so now we can multiply this by 1/2. 125 times 1/2 is, I don't think I finished this. Once I found r, I was so excited I stopped. All right, let's see if we can do it together here. 125 over 128. And then I'd multiply by 1/2 again. 125 over, what's 128 times 2? 16, 5, 256. And multiply that times 1/2. And I get 125 over 256 times 2. 512. And lastly, 125 over 512 times 2, 1024. So, we finally found the 14th term. All right, that will help you on some of the ones that you will see, and hopefully that even made sense. All right. All right, that's all I'm going to say for now. I will make sure that you get good practice on these things come Tuesday. I'll see you then. Good night.